Hi, good afternoon. I hope you had a nice coffee break. I'm a little bit nervous because I'm the only girl talking today. So, God, let's see how it goes. Okay, so welcome to this second panel where we will be discussing future CBM deployment. So, actually, we've touched some of the points in the previous panel, of course. But one thing that we have been seeing over the past years, probably decades, is that the condition-based maintenance approach is becoming mature, more and more mature. We see now CBM being applied to industrial settings, for example, or railways, or something like that. So, but when we talk about CBM in aviation, that's a lot of a different story. I heard some words in the previous panel that really made me thinking, because I think it was Theo that used the word or the expression "small steps," taking small steps. And I don't know who said that, but someone said that CBM in aviation is actually in this infancy. So. This is quite nice, quite a nice time to talk about the future. So if we are still a little baby or a little toddler, so what do we see over the next year? So that's what we will be discussing today. So with us, we have Vincent Gross from Airbus. We have, please. Yeah, you can be seated, please. We have David Piotrowski, did I say that right? From Delta Airlines. And Marc-Olivier Legrand from Collins Aerospace. So I'll be seated now. I will ask each one of you to present yourself. Short presentation, 5 minutes for everyone to get to know you. So we can start by Vincent, okay. Please.
So hello everybody, my name is Vincent Gros, I'm working for Airbus. I am the senior expert on maintenance operation for Airbus. My main activity and my 100% time, I would say, to focus and to think about what could be the future maintenance concept of Airbus for future aircraft. You heard about zero emission aircraft, for example. Yes, we are trying to understand what we need to do on that aircraft. And the same for all derivatives, all future aircraft that we can think about. And I'm also leading, not only for Airbus Commercial, but for Airbus Group, covering helicopters and military aircraft as well, the R&T roadmap linked to maintenance and more globally to all type of operations.
Thank you. David, please.
Hey, I'm David Piotrowski. I bring the operator end-user perspective. So I'm an engineer at Delta Tech Ops in Atlanta. Our operation is quite huge, and so I'll be talking about some of those challenges. In addition to that, I've got engineering degree plus an MBA, plus I've got professional certification in non-destructive testing, which is largely each individual task is going to be replaced by SHM. So I've got kind of a little bit of everything. I am upcoming chairman of the Aerospace Industry Steering Committee on Structural Health Monitoring. I'm also a member of the Integrated Vehicular Health Monitoring Steering Group. And with that, we're working with more and more of the regulators. And then A4A has the MPEG group, which is Maintenance Programs Industry Group. And I'm a member of that and working with the Structural Working Group on trying to institute some more structural health monitoring and seeing what needs to be revised regulatory-wise or updated regulatory-wise for us to extract as much value as we can from that. Because currently, we're not able to do everything that we can. And primarily, that comes down to not really a technical concern, but it's more of a philosophical. We operate under the scheduled maintenance system, and literally if we find damage, we have to usually replace that or repair that before further flight. The plane's grounded, kind of thing. So from an operator standpoint, putting more sensors on the plane is a risk of interrupting my operation if it goes off, kind of thing. So we need to find a balance of that. So that's a perspective I'm bringing today.
Okay. Marc-Olivier Legrand. So I am the Research and Technology Manager for Actuation System, dealing mainly with the primary flight control. We are based in Paris, around Paris, and we are a division of Collins Aerospace. My job, I consider that it's 3 missions. One is to support the roadmap on the primary flight control, meaning by that I try to identify what are the swim lanes that we must follow, for example, on the PHM road or on the EMA road. So what will be the future of our equipment, because we are delivering equipment. The second mission is to try to identify the projects and try to get the funding and to win, in fact, to win some projects so that I can walk on the roadmap. And the third mission is to coordinate and to try to align the R&D teams so that we achieve what we have committed or what we have foreseen into the roadmap. In terms of product, what is actuation system? We are mainly delivering actuators or actuation systems for aircrafts. One of our main customer is Airbus. So Vincent is one of my main customer. But we are also delivering Airbus helicopter, a lot in Marignane. So helicopters. We are also delivering Dassault in France. Embraer, we are making the primary flight control for the KC-390 military transport from Embraer. And unfortunately for them, we are, or for us, I don't know exactly, we are also providing the Irkut MC-21 aircraft, but now it's clear that we are not providing a lot to the Russian. It's a kind of closed item today, at least postponed. In terms of product, what means actuation? It's everything which moves a surface on the aircraft. So primary is the spoiler surface, the elevator, the rudder surface, or I missed one, elevator, rudder, spoiler, ailerons. That's the fourth one. And also we are providing the THSA, which is the actuator which is moving the tailplane. Maybe you don't know, but the tailplane is fully moving, and it's a very critical item because it's a fail-safe item. It means that it can operate even with one failure, whatever happens, whatever kind of failure. Why? Because if you lose this actuation, you lose the aircraft. It's a very sensitive one. That's one of the most sensitive, probably, equipment. And in fact, that's the primary, what we call the primary flight control systems. But also our sister entity in UK is providing all the high lift systems, which is trailing edge actuator or leading edge actuators. That's our main business, you know, our customer, our business. And why I am here and I am interested, it's the fact that I mentioned the roadmap, and it's clear that there is a road to PHM, and as we are providing actuators, it's clear that we need to understand where the world, the aeronautical world is going. And what is very interesting, and it was amazing because I was at the start of ReMAP, and when I see what they achieved, I said 5 years ago, and we discussed with Bruno, I said, if you had tell to me, we will achieve that, and thanks to KLM, thinking that KLM really act against the results of the algorithm and really make some additional maintenance on that, it's really interesting because it proves that even if it's a research and technology project, it can deliver things which are useful and for an airline, which is important. Because I think we all have noticed that the business case is the thing which is driving the world, unfortunately or fortunately, I don't know, but it's the case. And so I was here to understand where we should go in terms of PHM into the equipment. Of course, we are trying to promote a more physical model approach because we don't have the data. The data, and we have all understood, are owned by the airlines mostly, and of course Airbus, but the airline. So we are not at this level, so we are trying to promote the physics-based model, but probably both data-driven approach and physics-based model are needed, so we have a role to play, and that's really interesting because ReMAP really opened a lot of opportunities, and thanks to the team, the ReMAP team, it really opens the opportunity. But now, which road we should select, and we discuss with Vincent. Okay, we probably know where we want to go, but we don't know exactly which is the right road to go.
Thank you for this presentation. I will probably start off by the main factor, or one of the cornerstones of every deployment, not even CBM, in every technology, which is trust. We need to trust CBM in order to deploy it, in order to use it in our daily life. So, and at this point, we are not yet there yet. So we need to build this trust towards the technology. So my question for you guys is how to build this trust. How can the ecosystem trust the technology in order to use it in daily lives? Please.
If I may, I would say that it's clearly will not achieve and will not deliver the full CBM value in one day. Clearly, I think, Bruno, you said 2060. I think you're a bit optimistic. Perhaps later. No, I'm joking. We hope to introduce it earlier into the system. I would say in Airbus we have started, and other Boeing and others already started as well. On our side, we started with Skywise, focusing first on preventing operational interruption, unplanned event, I would say. And first, this gave trust to us that we can do something. It provides as well trust to our customers that we can also provide some value and some cost saving at least. So it's a first step really. But between that, which is for topics which are not safety related, and looking at the extreme vision that we can achieve with CBM, covering 100% of the component of the failure conditions of the aircraft, clearly there is a big step to do, and it's clear that one day we need to design an aircraft for CBM. I don't know to which point we will achieve it, but we need to think about it and go in that direction. But it's not only the operator of Airbus that we need to convince. We need as well to convince supplier. I think suppliers are keen to come with us, but also it is have to be convinced. And for that, we need to demonstrate to them that we will have this equivalent level of demonstration and safety right from day one when we will apply the CBM. And for that, it means that step after step, starting with some use cases, non-safety related, could be economical or operational. But first we need to show to them that, yes, look, replacing this standard task that it is performed periodically to more condition-based task makes sense. We will run it in parallel, I think. We will have two programs in parallel, one using the CBM and the other the classical ways of working. Starting with some examples that we can either inject today on our current aircraft or tomorrow on derivative aircraft that we can put in place, because it could require to put in place some new capabilities on board the aircraft. And again, with that, we can get a bit of confidence and going in, like that, step by step, up to perhaps one day CBM aircraft. Okay. It's not only about the certificability of the topic. It's as well about the trustability of the data itself. Behind the topic, you have cybersecurity. You have we are going multiple chain in terms of for the data. It will be produced by the aircraft, by a system. We need to ensure that the safety is ensured between the sensor to the where it is stored in the aircraft. And we didn't touch a lot to that point during this afternoon, but I think the idea is really to go as well to send that information to the ground, and in order that information is treated and analyzed on the ground. So it put as well a lot of expectations and constraints on the what I call the ground segment. I don't know if you all understand what it means behind that, and a lot of expectation in terms of certificability and as well trustability of the data. And it's another point that we need to touch and start gradually to develop.
Excellent. So when I hear the word trust, I kind of interpret that as reliability. And so a lot of my focus is on the structures with structural health monitoring. And so that basically means proving that you have equivalent or better sensitivity than the task you are replacing. That's called probability of detection. And so you've got to prove that you've got your probability of detection on that. Included in that is your receiver operating characteristic curve, which is basically false calls kind of thing. From an operator perspective, if the sensor goes off, it better be right. If I'm going to stop the airplane, which basically translated means ground the airplane and have no further revenue, it better be right, especially if I'm going to remove a galley to investigate that and so forth. So those are kind of required. Now, the sensitivity and your repeatability of your experiment, that's all wrapped up in your reliability. But there's also a environmental durability piece of that in terms of your repeatability for that. And so we have treated sensors basically like a piece of avionics that we would put on board. And we require it go through certain checks, D0160, D0178, D0254. Those are industry specifications on basically doing the environmental checks. So temperature, humidity, vibration. Vibration is huge in our industry. And if the sensor is basically debonds as a result of vibration, that's no good. That's no good. So, and we'll need to see that in the data package before it's all approved. So that data package has to be a huge level of trust. Basically, prove it, kind of thing. And that's what the regulators say to us, and so forth. Now, as an engineer, I'm comfortable with that. I'm comfortable with letting the data speak for itself and go, okay, we ran these tests and they passed, and here's the reliability, here's all of this. That's good. So the other aspect of trust, sharing data between entities with OEMs and so forth. A lot of the airlines, we don't trust the OEMs, kind of thing. We think they're out to, well, make their business case to figure out how to make us pay more money, kind of thing. And realistically, that's true. Because we see the OEMs pushing more and more into the aftermarket, not just the manufacturing, but utilizing or selling basically services. Monitoring of your system or the health of your system or engine and so forth can be a huge part of that. So the good news is there is room for everybody to make money, kind of thing. But at the same time, it has to be balanced to where everybody wins, including the sensor vendor, the OEM, operator, and everyone in between. So it can be done.
Okay, thank you.
Yes, and I may not add a lot to what has been said. I think covers nicely the trust. First is that we trust everybody because we are the tier one, so we are happy with everybody. We don't want to blame anybody. But for us, I would say that as an equipment or system manufacturer, it's much more simple, the trust. I just want to introduce this idea is the fact that you have certification rules. Airbus knows how to certify its aircraft, so it derives some specification, requirements, and so on. And then we manufacture the product according to the requirements. So for us, trust will be embedded into the specification. So we don't question about what is trust. It is what Airbus believe is the trust. So that's first things. And the first idea. The second one is about trust for the airlines, which is an end customer for us, but not a direct customer. It's important to understand what is trust for the airlines was, because the business case is there. Who is earning the money? Who got the business case? It's the airline. So we need to understand for them what trust of the data is, because if we don't understand it well, we will embed some things which is not really what you need. And it's clear that Airbus can understand trust because against certification, but at the end, your understanding of the trust could be different. And so I would divide it. First, data exists. So trust of data exists. That is one thing. And but the more they will impact the safety, the more the trust we need in this data will be needed and increase the level of the trust you need. And what means trust in this case? I think it means that it's traceable, and Vincent mentioned that already. So it means, and you know, in the aeronautic, even a single screw is traceable. So of course, data will be fully traceable, which brings the idea maybe of the security of the data, and it is already mentioned. So it must be reliable also. And I discussed this morning about the fact that, okay, engineering, and we are nearly both from the engineering world, we said, okay, my system is reliable at 99.1. Okay, and what do you say about the no-fault found? So you declare an alert, and the company is disassembling the equipment or is grounding the aircraft, and then no fault found. Okay, I ground the aircraft because you announce a failure which does not happen. Okay, that's something I think it's difficult to anticipate. We will see in practice what is no fault found, because it still exists in our world, probably. We are still receiving equipment that they are declared no fault found, so that's an item. So I mentioned data exists, they must be secured, traceable, and the last thing which is important, of course, is certification. We mentioned it. So the trust will be probably documented by the certification authority, EASA and FAA. And what is also, I think, important, and Airbus and they will confirm, it's the fact that we need to align both EASA and FAA, because if you fly in the world of EASA, it means you fly in the FAA world. So it means both. And on this subject, there may be some US and European discrepancies which may be very difficult to align. Because at the end, when Airbus is selling an aircraft, he is flying all around the world. So,
yeah, fully true. If I may just rebound on the NFF and for the trust, just to tell you a feedback from what we have done to prevent operation interruption and so on, with what we have put in place on the system we have put in place we have drastically reduced the NFF rate. So you see, we bring a new technology, and I think just showing that on those type of indicators we can have a gain, it's a way to create trust. And I think we divided by 10. We divided by 10
with time
the number of NFF, which is
That's a good point.
I think a good achievement, motivating the full community to go and to progress step by step to the ultimate vision.
Right.
Okay, good. Thank you. Another topic that I wanted to discuss with you guys is the green transition. So we are moving towards more and more towards efficient means of transportation. Of course, aviation is not exempt from that. So my question for you guys is, how do you see that CBM can participate towards this green transition? Please.
Start or you want?
Yeah, you can start, please.
I think there is three level of answer. I think what we can do today, and as explained very nicely this afternoon, or this morning, sorry, by KLM, the CBM, it can reduce the maintenance demand, what I call the volume of maintenance you have to perform, because you are more accurate, you perform when needed, first thing. It reduces as well your maintenance cost, but with that, you need less spare, you need less energy, you need less mechanics you send on the aircraft and so on. So at the end, you have not a big impact, but at least you have a first impact in going in the direction of sustainability. First point. Second point, I think CBM can as well support the transition to new energy. If I'm taking the example of SAF, for example, SAF we know that today are very expensive. And again, CBM trying to reduce maintenance cost, you could smooth, I would say you will neutralize, but you can smooth the impact of introducing new energies such as SAF. We can do the same for H2, or liquid hydrogen, but on top, what CBM can bring to that technology is, I think you know that if we go to liquid hydrogen, it's about cryogenic technology, and here it's creating a lot of challenge regarding maintenance, because we need to manage very low temperature. We need to manage an energy which is difficult to manipulate, I would say. So we need as well to decrease the human intervention on this type of component. We need to minimize as well the number of intervention because they are longer. For the time being, with the technology we know, with the physical as well, because you need to warm up and cool down components. You need to inert the components and so on. So with the knowledge that we have today, it could take time. And if we are able to intervene just when needed, and when we want as well, with appropriate GSE, with appropriate skilled people, because perhaps we need a new qualification as well. But I think the CBM can bring a lot of benefit, because we will do what we need to do on the right timing. So I think there's a brilliant future for CBM on that direction as well.
Okay, thanks.
So yes, it's, I'm saying, honestly, you guys here in the EU are miles ahead of us in the United States on sustainability and having those discussions. But realistically, the world aviation industry is responsible for just about 2% of the CO2 emissions. That's really not much, kind of thing. But realistically, we're a high visibility target. We have a target on our back, and it's already being talked about. Oh, fewer flights, how to travel smarter. We have to speak to this, and so I'm glad you asked the question. Initially, we are going to the SAF that you had mentioned, the Sustainable Aviation Fleet Fuels kind of thing, cut down on emissions. And we've demonstrated, had demonstrators and so forth. Great, wonderful. Now let's scale up. What I'm worried about as an operator are the unintended consequences of that and not looking at the whole thing. For example, we're running these alternate fuels in a system that was designed for other systems, other fuels and blends and so forth. And with that, I think there's going to be a demand to have better monitoring of our fuel system, better, and I say that because things may degrade quicker. Kind of thing, or it may be a surprise of a benefit that we expected a part to wear out that it doesn't, kind of thing. And so I think there's going to be a huge opportunity for additional sensors and CBM to at least monitor that impact as to what's going on. And a quick example, so another sustainability-driven success. So in the wintertime, the operations for de-icing fluids and these runway, putting fluids on the runway so that it doesn't ice over kind of thing. Wonderful, we have figured out some sustainable chemicals for that. They eat airplane brakes alive. Our maintenance for airplane brakes has gone through the roof because of those sustainable, it's caused us to have more maintenance. So from our perspective, it's kind of maybe a negative kind of thing. So it was one of those unintended consequences. We succeeded over here, but then made a lot of work go up here kind of thing. So with that, we need to think about, okay, we're going through brakes at so much more level, required so much more maintenance, so much more manufacturing of the new parts kind of thing. Sustainability-wise, it might be a wash. I don't know. But we haven't looked at that. And so that's what I worry about as an operator are those unknown effects, unintended consequences.
Yes. In terms of, if I take once again the vision of equipment manufacturer, I think it's first some very small benefits. It's the fact that we will probably sell or make travels less spares. There will be less inventory in the airlines because the condition-based maintenance will prevent to have AOG because we will repair before the AOG and things like that. So there is a small benefit, but I think it's a very minor one. I would probably talk about two other side effects. One, I think it will change radically the business case of maintenance, repair, and overhaul. I don't know if it's greener or not, but I think it's a major effect of CBM, because it's clear that the airline will probably try to get their benefits, which is obvious, and that's the business. And so it's clear for us. I would say the airlines are doing their job very well. They are buying some very cheap aircraft, and guess what? Airbus is manufacturing very cheap aircraft, and guess what? We are providing very cheap equipment. So it means that the margin we have on OE is sometimes difficult to find. Sometimes we don't find even. But we need the two legs, OE benefits and MRO. So if it changes the size of the legs, it will change our world. So it's not going on the greener side, and something it's changing the world. But for me, it was interesting to mention IDOM. And the last effect is about greening is the fact that if you are greening the aircraft, does not mean that you are greening everything in the aircraft. And I take the example of the more electrical aircraft. If you take only an hydraulic equipment, today it weighs 3 kilograms for a spoiler or something like that. It's fed by hydraulic circuits that we don't know, but it's 3 kilograms to actuate an aircraft. The next spoiler generation, which is fully electrical, will probably weigh 12, 15 kilograms. Where is the benefits? At our side, no. We are increasing the weight. So in terms of, where is the benefit? It's at the aircraft level where you remove all the hydraulic circuits and so on. And so for the green effect, I really think that if we go into CBM, we are going probably to make more complex equipment. Are they greener? More electronics? Is electronics green? Okay, not yet, but maybe tomorrow. Yeah. So it's not really going into the greener equipment, but we are serving probably lighter. Maybe if we monitor some function, we spoke about the structure to remove some weight. So that will be the benefit. At the aircraft level, there will be benefits. At the equipment level, to be seen.
Okay, thank you. Yes, Dimitris, please.
Yeah, I have a question now. Okay, better. To David. David, you said before, yeah, you please.
You are David.
Just kidding. Yes.
Indeed, the contribution of aviation to the emissions, to the global emission, is something between 2 to 3%. And you said that the target is on our back. We get this question also from our students, and I want to ask you, maybe you know why?
Well, I think it's because aviation is looked at as, well, kind of one of those luxury items. A not necessary, it's a nice to have. It's nice to go on vacation. It's nice to talk business face to face kind of thing. So you have to ask, basically generally, I think globally the air transportation system now is part of the economy. We've seen it just in the pandemic, and we parked a lot of aircraft. Oh my gosh, how are we going to get these medical supplies where they need to fast? Vaccines. The freight carriers are going gangbusters. They're flying like crazy because everybody wants their Amazon package that day. Really, I think aviation is part of the economy kind of thing. But I think that's the argument is that people see aviation and they think, oh, a luxury trip to somewhere in the Mediterranean or Hawaii or so forth, not necessary, and it's a luxury. And so, but that being said, we do need to speak about it because I would say those discussions are going to happen. So we need to, I would say, educate the world on how we can do this. So I'll point out that KLM has a nice advertising campaign on how to fly better, more sustainably kind of thing. And they've got actionable, measurable outcomes based on listening to their customer. Our customers now expect us to be a little green, if not all the way green. And so I think ultimately, everything, as the case with everything, it comes down to money. And with that, I think the customers are going to demand that the industry gets green on that. And so it's up to us to show them the steps we're taking. And yes, it would be nice to snap our fingers and go to full electric and full hydrogen, but there are issues, batteries and so forth. There's a lot of issues to overcome on that. And so it's going to be kind of a gradual process. And we basically, having the answer of, yeah, we're going to put these goals out there so that we can hopefully make it by the year 2050, that's not going to cut it. We're going to have to update people on the progress compared to the previous year, the previous decade kind of thing. And so it's a public relations exercise as well as a technical question.
Thank you. Any other question from the audience? Yes, Anarta has one. Go.
So again, for David, you mentioned that for you, the structural health monitoring is one of the focus. So in the commercial aviation, what kind of SHM problems you're looking at, or what are the SHM utilities you're using? Just out of curiosity.
I am glad you asked that kind of thing. Go ahead and lock the doors. I'll be a while here. Kind of thing. No, I got some good stuff. Good stuff. Basically, from an operator perspective, those tasks that are required that impact my operation are painful. So if I can find a better way to do that, that's better. So let me give you an example. We have required inspections all the time that we have to do on a certain schedule, usually cycle-based, sometimes hours, calendar days, kind of thing. We have to do that. And sometimes I need to do an eddy current inspection on certain fasteners. Well, those certain fasteners are in back of a galley. So on the 737, there are some inspections on the aft pressure bulkhead. Easy eddy current inspection. Problem is there's a huge galley in the way. So to do that inspection is probably taking the aircraft out of service for 5 days. So hundreds of man-hours of open up just to get to the area. The inspection itself is like a 10 or 15-minute inspection, simple. But then hours of close up to get back there. Then there's a risk that you might have done damage going disassembling and assembling. Then you've got all the functional checks of, if you move the galley, there's plumbing, there's power for all the ovens and so forth. You got to make sure so it's about a 5-day thing. And so what we are working on are putting sensors around these fasteners that detect cracking, and we are routing that from behind the galley up to a sealing location. And literally I go up and open a sealing panel, hook into there, press the button, I'm done in an hour. So I go from 5 days to an hour. I can do it overnight, and I do it personally overnight, usually in Atlanta at 2 a.m. Kind of thing when the aircraft is not operating. And so those type of things, taking the scheduled and morphing them into better operationally. So things like that. We recently have gotten approval to use CBM sensors on the Wi-Fi antennas. Now the Wi-Fi antennas, everybody wants their internet. So what we do with an airplane, we have what's called a supplemental type certificate. Supplemental because it's in addition to the original type certificate, and usually not OEM related. So what we have are these vendors that we partner with, and we poke holes in the plane, slap an antenna on it, and you get Wi-Fi. Wonderful. Maintaining that operationally is difficult because we've modified the structure. And unfortunately, I can't go, hey, Airbus, because it's not an Airbus problem. It's a supplemental type certificate. So basically, me, the operator, I'm stuck with that responsibility. And the supplemental type certificate holders don't have the access to the data that Boeing and Airbus and Embraer have. So a lot of their answers are more conservative kind of thing, like remove an air conditioning duct and loosen wiring every 30 days on an aircraft so you can get access to that area to do the inspection. Well, that's like crazy. It takes the aircraft out of service for a period of time and so forth. So we recently just got approval to use SHM for that specific task on that. So in the grand scheme of things, say we're proceeding one step at a time. I say the baby steps. And I mentioned that we're only able to do some of what we could, kind of thing. There's basically three different, I would say, ways of doing structural health monitoring. The first way is to plain just use it as an alternate inspection. And that's exactly where we are at right now. The FAA and the regulators have told us they want to review every structural health monitoring application on a case-by-case basis. So literally, for the near term, we're only at that, basically a third of the capacity. The other two are using the, I would say, monitoring the operational parameters, and then the key indicators. Things like, okay, you're not looking for cracking, but maybe you have some strain monitors, some strain gauges, accelerometers, and so forth, that give you kind of data into clues that something's going on there. Right now, we don't really have the regulatory allowance for that kind of thing. We do have, say, as an operator, I can put sensors on my plane and I can take data all I want, but getting it approved and using it as basically an airworthiness credit, actually getting credit for a certain task, is tricky, very tricky. So that's why we're working on some of the regulations with the regulators. There is a issue paper 180 out there in industry. So let me see if I can shorten this. So the Maintenance Programs Industry Group monitors the maintenance program of everything out there. It's made up of OEMs, operators, and vendors. And basically what we do is we look at how the fleet is performing and do we need to tweak anything, type of thing. One of the aspects that they work on are producing candidate issue papers to propose to the IMRBPB, the International Maintenance Review Board and Policy Board, which is a collection of the top 10 regulators in the world. And they basically get to rule on whether that proposal is accepted or not. Currently, we have basically MSG3. So MSG is Maintenance Steering Group. So the MSG3 document is, in civil aviation, is basically our Bible. It describes the methodology on how to maintain your fleet and decision logic, if you will. And from that, the OEMs then take that and create a maintenance review board report for every fleet. So for every aircraft type, they have this report and a list of items that need to be attended to maintain that airworthiness. Then from that, the OEM makes a maintenance planning document, an MPD, which are basically the list of tasks and when to perform them. The operator, then I take the MPD document and turn them into the actual job cards that the maintenance is performed on. So that's the whole hierarchy. So there's an issue paper, it's issue paper 180, and it is about health monitoring and changing the MSG3 document to allow an additional step in the decision logic of how to do maintenance. And that additional step, the additional level, is basically, can my health monitoring system detect and alert or alert me to that problem in time? And that's where a lot of the reliability comes into. That issue paper 180 has been accepted and is going to be put into the MSG3 document. So health monitoring, we're good. However, the gotcha is that issue paper is very clear that it is for non-critical, non-safety items, which really impacts the number of goodness that we can do, kind of thing. So structures very quickly get into critical. Pneumatic systems, hydraulic systems, flight controls, oh, those are critical. You can't touch those with health monitoring. And literally, that's the challenge we have today. So one of the things that I'll be working on is, with the regulators, is modifying the language to allow health monitoring on safety critical systems, kind of thing. And incumbent is that, in that is, okay, what do you need to do? How do you validate that? How do you prove all of that? And that's where some of this standards come in from the SAE committee. So we'll be working hand in hand with a lot of that. So did that answer your question?
Yeah.
I'd say it's a long-winded way of saying we got great news, and then we've got more work ahead of us.
Yeah, in the commercial domain, SHM has been a bit of, I think, where is the scope, and that was very nice. Thank you.
Right.
We have another question.
If I may, about SHM,
Yes.
I think we need to be, we cannot lie in that forum, I would say, or in this SHM. And I do believe that clearly we will not do a fully sensorized aircraft. don't dream about that, clearly.
We were talking during break, kind of thing. This ReMAP, it's wonderful. It's exciting. And I've told people we're at a very exciting time, and we're also at a very dangerous time because we have some people out there, airlines, individuals, kind of thing, that want to go out there and slap sensors all over the plane, all over the engine, and we just measure everything and then see what we see. If we do that, that's not good.
No, after we will come to very complex aircraft as well. What will be the impact on the global reliability of the aircraft? What will be the complexity to operate the aircraft? Alors, there is the decision tool that KLM has developed is very good. But I think for KLM, it's very good because they're able to use that tool, to operate that tool. Because there are other key, Delta can do as well, no problem. But how many operators in the world can today operate with such tool? With a limited number of engineering people in the organization, could be more complex. So we need as well to find the right balance with not too much complexity and the efficiency of what we are doing. Voilà. And it's true for SHM, it's also true for systems, for sure. Right. And I think we will, one of the messages I want to pass is we need to work on the technology, for sure. It's what we are doing brilliantly today, no problem. But don't go too far away. I think each sensor, each piece of CBM component that it is put on the aircraft, even on the ground as well, has to justify its place on the aircraft. Because even myself, when I'm discussing with my chief engineer, so for my future aircraft and so on, the first question that come back to me is, Vincent, what is the price? What is the value? What is the cost you will add on the aircraft? And after Mr. Delta has to pay it, I would say. And as well, the price to operate the CBM system. Because behind it, you have to store a vast amount of data. You have to do a lot of computation. You have to store them for decades as well because you need the traceability. So behind that, you have cost. So we need to be very clear, reasonable, but really focusing on what things are making really the difference, I would say. I don't know if you share.
So initially, when we talked taking those baby steps or building blocks kind of thing, it's not really mean to kind of criticize ReMAP or the efforts. It's basically realizing that if we overpromise and underdeliver, we will set things back decades. So we need to take small steps, a couple of good wins that we can advertise, and then we can whet the appetite of people that they say more, 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 and then we go to the next step and the next step.
Yes, Katerina, please.
Hello, good afternoon. This panel and also the previous one focused a lot on false positives. And usually when people are outside this area, do you think that maybe contributes to that target on our backs? That because false positives are a problem if you are trying to save money, but if you want CBM to replace the scheduled maintenance we have today, you should focus on not having false negatives, right?
Right. Agree.
Who wants to grab the question?
As you want, take it.
Now let me see if I got this right. You're asking, business case-wise, we have to have the value. But then sustainability, we're going to be forced to do it regardless of the value. Well,
it is a value, sorry.
There is value, yes.
Going in the direction of sustainability is, as itself, a value.
That's right. So we've got to look at it basically that way. A lot of the problems in the world are because we've got this little narrow vision in my little niche, and we're not seeing the bigger picture, the globe, literally. So yes. Did that answer your question, or were you?
I think so, yes.
Okay. If not, just see us during afterwards. We'll be glad to help.
We have another question here from Floris. Can you grab it? Okay, cool.
Thanks. Yeah, I think it's in addition to your question, Katrina, but also to the very first discussion point in today about trust. I think if you talk about CBM, there's always two discussions that are very separate, right? So one is to avoid unexpected maintenance by anticipating failures. That's one part. And then the second part is by reducing periodic maintenance, right? Yeah. By basically doing less maintenance. So for the last part, of course, you need very few false negatives. I agree with that because it's safety critical. Most of the times you don't want to miss anything, yeah. Otherwise it's not going to happen. But for the other part, I don't think I really need that high accuracy of a model, right? Because today we don't have anything. So if we would add a system that gives me a little bit more accuracy already, then if it gives a couple of false positives or false negatives, I don't think I care as long as at the end of the year my business case is net positive. So when we discussed about trust, I think yes, we should trust and make it trustworthy and reliable. But we should also train ourselves to deal with systems that we cannot really trust. We have to deal with that uncertainty, I think, because it can still give value if the accuracy is not 100%.
Right.
Glad to hear that from a customer, because in most of the case, when I'm in front of customers, they ask me, Vincent, you need to be 100% true each time, whatever you say, being on avoiding unplanned maintenance or being on removing scheduled maintenance. So I'm glad to hear that. The other customer doesn't have this tolerance, I would say.
Right.
Yeah. But I think it's really the CBM is, in terms of operator processes, you can contradict me if you don't agree. It's really a big change in terms of mindset as well. It will deeply impact the way you operate the aircraft, you think the maintenance and so on. You need to change some tools, some processing and so on. And I do believe that some airlines, if they do it, if they invest into that, they want to be paid to be paid very quickly. So it means to get 100% of accuracy and so on. Wow. Right. I don't know if you agree, but
I'm gonna kind of disagree.
Okay, good.
Basically, it depends on your perspective internal at the airline. So if we have a system and it goes off and it gives us an alert, and it turns out we do some maintenance actions and investigate, and it turns out to be false or no fault found, guess who gets a phone call in the middle of the night saying, what the hell are you doing on my plane? You're messing with the operation. Take your research and so forth. That being said, that's, like I said, that's their little world. Keep the operation going. And here I come and I mess with their world. Now, in the grand scheme of things, the long range, big picture, we are going to need a learning curve. We are not going to be perfect, kind of thing. So there needs to be a balance, kind of thing. And the OEM and the operator need to understand that, kind of thing. We have, I think it's your competitor, we have a tire pressure monitoring system on board. And the reliability is so horrible, we deactivated the system. It's still physically on the aircraft, but we have deactivated it and went away from it, kind of thing. Now, some of the reasons it had poor reliability were environmental. Basically, the wire was getting corroded and basically had a problem with the connectors, kind of thing. Really not a problem with the technology, but the way it was implemented, the process. So it depends on your perspective. And yes, that puts a lot of pressure on me to go to the operations center and basically say, you may have something that pops up and it may not be right, but it's okay. And then they yell at me a little bit, kind of thing, and then we go for a beer afterwards and everything's okay, kind of thing. But it's that type of thing. It depends on internally. Then obviously every shift, we basically have an operations call kind of thing with the senior management and our chief operations officer kind of thing. And you don't want to be on that call as a problem kind of thing. Well, we grounded this aircraft because David said there was something that may be wrong kind of thing. I'll be in the chief operating officer's office real quick. What are you doing? But that's some of it, and some of that is the industry education. I've got to educate people internally at Delta, as well as to what we're doing and why we're doing it, kind of thing.
In a way, also with the economical hard time, I think we're doing the same. We also have a super unreliable system. I won't comment on the OEM that's making it, but it's so bad that we are considering a hard time now. And a hard time is basically also an action where we don't even care about the condition of the component, right? So my take would be just try, if we can put a sensor on there, then at least we know a little bit more than a hard time, because with a hard time we know really nothing.
Right, because our reliability, our field data is basically not making us trust the OEM or the supplier on that, because they said, here's your maintenance program, and if we've got so many failures, it's impacting us, we'll take remedies kind of thing. And it may be just, okay, they say it lasts 10,000 hours, and we are finding after 4,000 hours, we begin to get failure. So 4,000 it is, and we institute a hard time limit. Really kind of short-sighted, but solves the immediate problem of failures in the field. Now, realistically, we're throwing away green time, we're doing extra maintenance, and so forth. So it's really not good, and it's not really the right answer, but it takes the heat off the operation. So that's a good point. Uh-oh.
I'm a Come on, I'm a girl.
So my KLM counterparts
Nice
are.
play, yeah. Nice game. Huh?
Yeah, thanks.
So Walter,
This game, I lost.
So perhaps I'm just having a brain fart or not, might be. But yeah, we're discussing CBM, which in essence should replace interval-based maintenance tasks. So if you were to use a BHM system and you have got your alerts going, I would compare, in a different way. Whereas with the current system, basically every maintenance check that shows no actionable outcome is actually a false positive.
that's
Right.
a good
So
way of doing
you
it.
have to do the apples with apples comparison somehow. So we can say that when designing future CBM, it actually allows for a level of false positives there.
Yeah.
No false negatives, of course. No, absolutely not.
Right. I've got a slide in my presentation tomorrow that basically says like roughly 80% of the out of service time for an aircraft is due to the scheduled maintenance requirements and implementing our scheduled tasks. And 90% of those result in no actions kind of thing. The aircraft's good to go. Think of the time and think of the money we just spent to, in effect,
I guess that's
get
where,
the wrong answer or
So that's where we're not making the argument nowadays, because everything we do on using prognostics is extra and it's economically
right.
driven. Whereas a first step to real CBM, where we can drop or perhaps start with extending maintenance intervals, you can go to your maintenance organization. I've got something extra, but you already took the win. So they're probably just leaning in a nice chair, just waiting for you to come by for some work.
Yes. So yeah, that's a very good point. We want to replace things, but yeah, a lot of times, we got to do the maintenance anyway because it's the way it's scheduled, kind of thing. So I'll give. I mentioned issue paper 180 and allowing health monitoring for essentially maintenance credit or airworthiness credit. 737 environmental control system, basically an air filter. We have a scheduled task that says to replace that air filter every 3,000 flight hours. So no problem, but knowing that, well, that 3,000 flight hours is based on either the average usage or the worst case usage kind of thing. But say, and we've put sensors on just simple pressure and temperature kind of thing. We notice some degradation. And so by, say, 2,400 hours, we notice it's clogged kind of thing. We go out there, we go out to the aircraft, see, yes, verify, it's clogged. Change the filter, wonderful. We get no credit. We still have to go 600 hours later and change the filter because the scheduled task says change it every 3,000 hours. We don't get credit. We don't even get zero timed kind of thing. And this is some of the things that we're going, this is nuts. We're doing the maintenance, basically avoiding an in-flight event, or in this case, basically the air conditioning system probably wouldn't work. It wouldn't be critical, but our passengers would definitely notice and probably not like it, kind of thing. So those type of things, I want to get credit for. Structures. I want to get credit for hydraulic system monitoring kind of thing. Right now, we can't even get credit for replacing an air filter. And so that's why I say, but it's coming. It's coming. So.
Any other question?
So just a small comment about the false positives and false negatives.
False positive, false negative, yes.
Yeah, from the machine learning perspective, in the model, reducing one or increasing one is just a matter of changing thresholds. We can always have a trade-off in the algorithm to play with that. So at the end of the day, it depends on the cost of a false positive and cost of a false negative. And using that cost, right, you can optimize. You talked about the ROC curve, the operating point on the ROC curve, which one you want, choose. Whether your recall and precision rate, it's the kind of trade-off between those two.
Right.
So it depends on the component we are working with. If it's a huge equipment, a false positive leads to thousands of dollars of inspection task, then false positive is not acceptable. And if it is a small thing, it is just few dollars to check, verify, then it might be acceptable. So it's all about the cost.
Right.
And then you can choose the operating condition on the ROC curve you want. So
and I can probably go on for hours about how much no fault found cost us,
yeah.
kind of thing. So it's a pain.
Yeah.
It is an operational pain.
It's about cost and aircraft availability as well.
Pardon?
It's about cost and aircraft unavailability generated by that. So it's not only about maintenance cost.
Yeah. So the cost,
yes.
by cost I mean the total thing.
I agree, but I think it's better to share that with the community.
Right. Right.
Guys, so let's change the topic a little bit.
Yeah.
Let's look into the future. So we are still in the green transition area. So we are seeing more and more new aircraft design with new technologies, new fuels, and so on. So how do you see CBM impacting this new aircraft design in terms of system complexity, in terms of redundancy of the systems, and so on? So how do you see this? What kind of airplane will we have 15 years from now? Something like that.
I think the question is for me,
yes,
more or less.
Mostly.
We'll not disclose too many secrets, perhaps, but I can share. Clearly, the goal is not to complexify too much the aircraft, as I said. So clearly, the idea is to inject into the aircraft the needed ingredients in order that we can observe more parameters and the appropriate parameters in order that we can really impact maintenance cost and the aircraft availability linked to, as you said, no fault found for unplanned maintenance, but specifically as well for planned maintenance. We really want to reduce this maintenance demand. So we need the appropriate information It can be information that are today already produced by the system on board, which are not exported, and we need just to make the link, to allow to export them. For highly justified cases, for sure, it makes sense to add the appropriate sensors, but in that case, we need to take care of the reliability of the sensor. We need also to have the fallback plan if the sensor fails. What does it mean? Can we come back very easily to the classical MPD, as you mentioned? Or what is the plan we can have? After, we need to store the information on board the aircraft. Do we need to send it to the ground immediately in real time or not, later at the end of the flight, the day, the week, the month? I think it depends on the criticality and as well the frequency you need to acquire the data. But after, the idea is perhaps not to keep everything on board, because I do believe personally that we can do very smart things on the ground. And if you do that, perhaps you will reduce the weight and the impact of your onboard maintenance system if you are able to demonstrate that on the ground you can do a lot of things. But it puts as well a lot of pressure on the ground segment. As I said previously, you need perhaps to certify, you need to justify many things. So you see, perhaps you complexify the ground part and optimize, I would say, the board aspect. And it could be a vision. I'm not saying it will be, but I think it's something making sense, but you have a lot of challenges, clearly. A lot of challenges.
Yeah. Ideally, I don't want to do maintenance unless the aircraft or engine tells me. That would be our ideal kind of thing. Now, regulators, with all the PHM and so forth, they keep telling us that they want a human in the loop somehow. Now, that may be just verifying that your machine learning algorithms are valid and are working kind of thing. So that may be a lot of behind-the-scenes stuff. We are entering a phase where we are getting more into the predictive. And with that, we mentioned there's an IT component kind of thing. So we are hiring data scientists, and literally engineers, and then we're hiring data scientists to dig into a lot of that. And if you've got both kind of thing, you can virtually guarantee a nice career in aviation with that. Now, I would love the ideal case of going straight to CBM and not doing maintenance unless it tells us, because we have all that trust and all the regulations. Wonderful. Realistically, there's going to have to be a transition period where there's a hybrid, where we're going to do some things with CBM, but we're going to have it overlaid with our current scheduled maintenance system. And then we're going to be able to pull a little layer off at each time, kind of thing. So that's where we're talking kind of baby steps. Initially, the non-critical stuff is ripe, and we can start attacking that right now. And if we get a few good wins, economic, and show the value kind of thing, and sustainability kind of thing, then that's going to just whet the appetite for more and more. And then basically the curve for implementation and acceptance and adoption is going to go exponential, kind of thing.
Yes, just maybe a few points about equipment systems. First, we have a philosophy where we said data exists, and if we add sensors, reliability will go down, so we may not add sensors. So we do not make it more complex, and the sensorized aircraft may not happen. So that's the good news.
So adding a sensor, the reliability may go down because we find more information that we didn't want to find?
No, in terms of FMECA, if you make the FMECA physically, it's the truth. But
right,
at the end, the global calculation is maybe different. So that's the philosophy we try to maintain. But it's clear that if the data exists, it's clear that the way we use them is not smart at all today. So we need smarter actuators. What I mean by that, and I think there are maybe 3 steps. One is first, the actuator or the system is able to record itself the data and to transfer it to the aircraft. Because today he's not transferring anything, he's just talking with the aircraft, and the aircraft says, oh, this data is not correct, and so on. But he's not making any assessment on the data today. The equipment or the system are not assessing if the data are good or not. They are just transferring data, orders, powers, and things like that. So maybe first analysis, first capturing, recording, assessing the data, then probably analyzing, saying, okay, this set of data may indicate something, and even he can, if the power for computation is more complex, he can say, okay, my remaining useful life for this system is 3 months, 1 day, or something like that. That could be the trend. So smarter systems, and probably more communicating. We don't need to put the smart things into the system. Maybe it could be at the aircraft level or at the ground level, because maybe the computation needs may be very high, and it's clear that the room left into the electronics we are fitting, it's clear Airbus wants small electronics, and we can't put all the power for computation we need. So maybe more communicating and not so smart. And we can even think to things which can be adapted to the environment. What I mean by that is that they can be fault tolerant just by command, saying that if they see that there is somewhere in the electronics or in the mechanical system, they can say, okay, I shut off this part and I activate another one, so they can reconfigure themselves automatically because they have a small brain and send the aircraft information, or please don't use this area, but for example, when you fly, don't use this spoiler, but compensate with another
It's already done.
Huh?
It's already done at aircraft level.
Yes, but it could be done at a lower level. But yeah, the interest maybe not. Yeah, no. And yeah, I think that was the things I want to mention. I try to remember if there was a fourth one, but I don't think so.
That reminds me of basically the acronym SATAA that we're using in several of the health monitoring committees. So basically the process, S for sense, you got a sense there. Then you've got to acquire that data. Then you transfer or transmit kind of thing. That may be on airplane, that may be off airplane. Analyze, and then action, take action kind of thing. And basically that's it in a nutshell. And in between, or each of those steps, there are opportunities to get better. There's an opportunity for a better sensor kind of thing. We can do the transfer quicker. We can, instead of ground operations, we can put things actually on the plane to adapt kind of thing. So it all fits right into there. And there's a lot of work that can be done in each one of those and in between those. Yeah. So that's what I heard you say.
I remember the fourth things I wanted to say. I think you have a phone, a smartphone especially.
Oh, yeah.
And you know, smartphones are well known to be very smart, have a high computational power. And you have CBM in it. And you know what? You have one information, battery status.
Battery status.
The only one
everything.
probably. Mm-hmm. You don't know what happened. You don't know if it's operating well. You have only one, battery status. And so, to come back, maybe our actuator will be very simple, just transferring data, and that's all, nothing else, because the work will be done at aircraft level.
Again, on that topic, it's a trade that we need to do together.
Yeah.
I think it's a bit reflecting the CBM context. I think there's many things that we need to do together, otherwise we'll never achieve it.
It's clear.
Right. And so, while before I forget, Monica, I was mentioning where we need to go in the future is more of industry education. And by that, I mean everyone in this room, all the way from researchers, all the way up to commercialization, OEMs, suppliers. operators and regulators need to have an industry education internally with me at Delta kind of thing. And I say that because, unfortunately, Bruno might be mad at me on this, CBM. We love that acronym, CBM, Condition-Based Maintenance. When I say that acronym, it is a trigger word for some of the regulators. And it triggers them to basically say, you can't do that automatically, because they don't know what the heck it is. Mm-hmm. They hear that and they go, oh, you mean on condition as in run it to failure and take no action and just replace it after that. You can't do that. You got to have better reliability. Same thing with the word monitoring versus management. Structural health monitoring, structural health management kind of thing. The word monitoring implies, oh, you have a condition, you know about it, it's bad, and you are choosing not to do anything about it. Not only is that unairworthy, it's illegal, so you're out of compliance, you're not safe, and that's when they talk about people going to jail for endangering the public kind of thing. So in these trigger words, we need to have some common language kind of thing, because if the regulators get triggered, then the next thing you know, they're not willing to talk and listen on the next thing. Even though we've got the data to show, hey, it's a data-driven philosophy. It's not just an idea kind of thing, it's data-driven the whole way. So where we're going is a data-driven, tail-specific or asset-specific maintenance philosophy kind of thing. And when you say that, they're like, oh, so you got the data for it. Yes, I have the data for that. As an engineer, I'm comfortable with that and can prove it.
So we have a question from the audience.
Thank you. Yeah. So Bastiaan van Greenveld from Airbus. I have a slightly philosophical question. Are we in danger in the future to create some sort of two-tier system where the smaller players, the smaller airlines can't cope or can't finance using a CBM system, and are left behind?
Some. And I say that because some of the conversations I've had with regulators, or even Boeing and Airbus, have been like, I'll let Delta do it. I'll let Delta and KLM and American do it, but I am not putting in writing because I don't trust airline XYZ to do it because they don't have the capability. And that's bad for the industry. So we'll have pockets of success, but really limiting it kind of thing. So it comes down to a choice. And so you can either do the CBM or you can maintain it with basically the scheduled maintenance. And for some operators, that's fine, and they're gonna do that. Now, some of the smaller operators, they typically lease aircraft and they don't own the aircraft, and then they give their aircraft back at the end of the lease. So business case wise, they're focused on their just little 6-year lease kind of thing. So leasing companies, I think, are a key aspect to this because they got the asset and they want to make money on the asset for 30 years. It may be 3 or 4 different operators that do that. And so the leasing companies could mandate, you will maintain the aircraft this way, kind of thing. That's within their rights, kind of thing. And us as operators, when we return a aircraft back to the leasing companies, it usually has to be in a certain condition or certain configuration type of thing. So Delta, we own most of our fleet, but we do lease on some because there's some financial benefits to that, tax benefits kind of thing. So we have a blend. So we deal with leasing companies, and then we've got our own fully owned aircraft. So, but yeah, the idea is there will be carriers that won't choose to do this type of thing, and we've got to make it to their value proposition. So they basically say we're going to have this aircraft for only 6 years, and after that, no problem. So to them, it's not worth it. But
does that mean we end up developing both systems in parallel? Some for the guys who can cope with it, and the old-fashioned system for the others.
Possibly.
Doesn't sound
And
efficient.
that makes it not very economical for the OEMs and so forth. But
it's as well a step towards the full implementation as well.
Right.
So it's a transformation of the aircraft, the transformation of the regulation, and the transformation of the operators as well. And we need to do that in parallel.
right.
And, and perhaps but you need to help us as well. How do we see the context of operations in 20 years' time? Even the small company, airlines, sorry, do they stay as they are today, or do we imagine they will evolve as well? And if they don't, how we can support them to evolve?
Right. Now, at Delta, we do work for other airlines. We actually overhaul more engines than we do each year than we do for Delta. We have a couple of customers that basically say, we like what you guys are doing. Please maintain our aircraft exactly like you do, your fleet kind of thing. So we have a couple of customers that we are doing their maintenance for them.
And you are cheap enough.
Somewhat. We demonstrated the value.
Yeah, exactly.
Primarily because even though it may not be the cheapest, lowest cost, overall, you give them the best reliability. They like that because better reliability enhances your operation. The opportunity cost of the lost revenue from having an aircraft out of service, reputation of your brand. If you have an airline XYZ canceled flights this weekend. I mean, when the airlines do bad, everybody knows it, kind of thing. We are very popular to be put on the news of so-and-so did this and cancellation this and stranded passengers kind of thing. So we don't like making the news kind of thing. So
Neither in Collins, I think, and it's the same for Airbus.
No, except for the sales.
right, record sales at
If
Airbus.
you don't sales, it's okay. For the rest.
Okay, can we have another question? I think we have another question here. So, you don't trust me now.
I was triggered by the apparent negative connotation with CBM. Is predictive maintenance a better term, you reckon? Or doesn't that
Yes,
cover?
yes, that is a better term. Doesn't trigger them as much, but it still has the connotation of basically sitting down with the lady with the crystal ball kind of thing and saying, ooh, I see something in your future. It may be fluff. It may be, that 1 in a million that they're right. And then everybody goes, wow, this is right. So I think it's still some of the, I would say, researchy question kind of thing, predictive kind of thing. Oh, the researchers predicted this kind of thing. And it implies that it's not ready for prime time, even though Delta has a predictive maintenance organization, American has a predictive maintenance organization. So that's why I basically prefer to just go data-driven maintenance philosophy.
Perhaps model-based as well. Huh? It's not
Yes.
about data-driven, it's model-based as well.
Yeah.
That's right, that's right.
Maybe there is a way, during this morning's Maria, I was thinking that, okay, condition-based maintenance is nice, but you see that there are a lot of limits. For example, KLM mentioned that, we can do the maintenance we want because it's regulated, okay. AI don't provide some actionable results. Okay, so maybe with Airbus and Collins we can bring some more depth into the results. And so I make the synthesis, okay, you are limited by lots of things, so the way forward is what? Don't work on CBM for critical systems. Why? Because you impact safety. If you impact safety, EASA, FAA, regulation authority will be involved. So don't touch that. And then you said, where is the business case? So it means that all systems are not interesting to be repaired by CBM. So, okay, you select the system which has the best business case, which is not critical critical, not impacting the safety, and which already have the data. So it means that don't try to imagine that your structure will be sensorized in 10 years, and then we will build the aircraft 5 years after, and then you will get 5 years after. So you begin with where the data exists, which means that the road is known, non-critical, not safety, not critical without safety impact, existing data, and with a business case. So I don't think you have so much systems which are in this case, so it's easy to go.
Right. But at the same time, I'm here as an end user. American Airlines is here. KLM's obviously here, kind of thing. You have our attention, so we are looking for this now. And we have had some successes now, kind of thing, but I'm impatient and want more. I want it faster and I want more.
Yeah.
So it's a good thing. Yeah, we're here, we recognize the value, and there's more in the future.
Okay, so we are a little bit behind schedule already. So I wanted to ask you a last question, and I want a short answer from your side. That's one thing. And another thing is I want you to focus on positive aspects. So we have been talking a lot about challenges in CBM. So I want you to focus on opportunities. And my questions for you guys is, how do you see CBM in 5, 10, 15 years from now? From a positive perspective, please. Okay, maybe we can start. Who wants to start? Yeah, okay. You don't need this. Okay.
I'll go first,
Please.
kind of thing. I think we are on the precipice of things about to blossom. And when that happens, the demand is going to go exponential, and it's going to get really good really fast. Now, so initially you're going to have your early adopters, your lead airlines kind of thing. So it's going to be the Delta, it's going to be the KLM, it's going to be the American, Lufthansa kind of thing. Other airlines, I will tell you, there are 17 other airlines around the world that have called me, cornered me, emailed me, and basically saying, hey, is this for real? Is this for real? Or is it just another research project kind of thing? Is this for real? What about the regulators? What about this? And so forth. There's a lot of pent-up demand and excitement that are watching things like the ReMAP program. And with that, I basically have said, well, it's going to take all of us kind of thing. So you send in a request to Airbus, and you send in a request to Boeing kind of thing, because Airbus and Boeing have internal resource challenges, and they need to hear from their customers that they want this kind of thing. And they're like, no, don't want to do it. They're scared of the regulators. They're scared of getting their hands slapped, and so forth. And a couple of them have told me, you stick your head out as Delta Airlines, and if the FAA or EASA doesn't chop your head off, then we'll come out of our hole right after you. So once we get that early adoption, some of the initial successes, things are really going to take off. So we recently have just gotten the first FAA-approved, regulator-approved structural health monitoring task kind of thing, with many more coming. So I'm thinking we are set for some good things in the future.
Thank you.
Really quick.
Thank you. Vincent, please.
So to go on the positive things, I think that CBM will unleash the value for as it is itself for reducing the maintenance demand, but I think it can go beyond and really create an opportunity to change the way the maintenance is scheduled today. Perhaps with CBM you can go beyond or going something different versus later checks or semi-equalized, or some airlines are doing equalized maintenance. Perhaps it could create opportunities to schedule and perform the maintenance differently. And think about it, because here Of course, we have some ideas, but it can really create additional aircraft availability to make the best revenue of the aircraft. And CBM is a real key brick in that direction.
Okay, yeah. I think ReMAP, the project, was really interesting because it really opens for me the eyes, and it's shiny eyes, as we used to say in our company. So I would say that in 5 years, it's clear that we need to really understand and to be focused on the airline needs, because they are driving the needs. Of course, Airbus can bring it, airframers can bring it. For example, I am as old as the fly-by-wire system. What I mean by that is I enter the company when the fly-by-wires enter in the aeronautical world. So it's, you know my age now.
That really wasn't that long ago in terms of...
40,
I'm saying you're not that old.
40 years ago, okay.
Yes.
Roughly. So I think it really needs to be driven by the airlines. Coordinated, and it was mentioned by Vincent, it's important. Airlines, airframers, and suppliers. That's maybe the road is not so clear because there are several roads, but there is a road. Now I am convinced because, as I mentioned, if I was told 5 years ago that ReMAP will deliver some actionable operation in KLM just because an algorithm says you need to do it, I would say no way. And in 5 years, they did it, so well done.
I agree. I looked in this same thing. I said, woo, they're asking a lot.
Yeah, exactly.
And you guys did it.
Yeah, well done in ReMAP. And I think we several times mentioned the fact that it's a need of change of culture. And I said, I have written, supported by believers. What I mean by that is that probably you need believers in the airlines, in Airbus, in the suppliers company, and we will engage the regulation authorities. Because it's clear it's not the airlines which will move the regulation, it's not Airbus alone, it's really believers in all these companies which will move that things. And I think in 5 years, the good news would be that several companies are using CBM algorithm to drive some simple maintenance action, and then we will go to more complex. And as mentioned by Vincent, even if there's no fault found, the maturity of the system at the beginning is not perfect. And probably that's something we have in the mind, that everything should be perfect at the first time. Okay, do right first time is a nice target, but who can succeed each time right first time?
Right.
Yeah.
Even for very simple thing. So if we begin with CBM in some companies and demonstrating that it operates, we will convince everybody.
Right.
Yes.
Thank you so much.
If I may,
Yes, of course.
last word. But the challenge is more on you in that case. I think with ReMAP you achieve a lot of things, and I think it's perhaps the time that to offer you to write your Christmas list to the OEM. Not only Airbus, it could be Airbus, but it could be Embraer, it could be Boeing. What do you think? And it's really an open question we can debate. What do you think we should do as aircraft manufacturer to make CBM a success? And I'm happy to get your feedback, and I'm happy to get your points.
So we're going to leave it to you guys. We'd like to continue this discussion over the next couple of days.
It's a bit that message, yes.
Yeah.
We need everybody collaborating and thinking. And the regulators, believe it or not, are actually working with us, kind of thing. They are supporting us, kind of thing. Now, if they do something stupid, they'll tell me I'm stupid, but so does my wife. So that's okay.
Voilà.
Thank you, guys. It was a pleasure to hear you. Bruno, I'll leave the floor to you.
All right. Thank you, Bruno.
okay, no? Don't you think?
Am I on? Yeah. Okay, so what a day, huh? Long day, very productive day. At least I have learned a lot, really a lot. It was very interesting. Besides many things, what we have learned is that we have more work to do than the one we have done. We already knew that from the beginning. ReMAP is not the end of something, it's just brought us farther than where we were before. But we still have to continue, and we have challenge addressed to us that we still have to solve in terms of training, educating people, in terms of technology, models, sensing technology, data, in terms of talking with the right stakeholders, making CBM to happen. And we'll be engaged on that. We have heard about that we need a ReMAP 2 or ReMAP 3. I'm not attached to the name, we can call it whatever you want. But indeed, we need to work together, and we are here to work together in the future. I like to thank you all that contributed to this discussion. I'm sure we'll continue to collaborate in the future. But most of all, I would like to thank all partners within ReMAP. We are here also celebrating what was ReMAP, and was a piece of cake in terms of coordinator. So it was easy to call someone if needed or during the meetings to ask something, and I would get that something and even more. And this means not only because I had fantastic partners and colleagues, more than the entities that are there, were the people that were involved with us. It doesn't mean not only that, it means that there is a community that is really engaged in addressing CBM. People were committed and involved in delivering, in getting a step further, in answering questions and getting 10 questions more, like you highlighted already today. And this has been an amazing experience as coordinator, as a researcher, as collaborator during this project. And I would like to thank my partners for what they did, and to congratulate everyone for what we achieved. Now there's still 4 months, but let's congratulate what we achieved now. So thank you very much, everyone. For you online, sorry, there are no drinks, but for us, there will be drinks. We can go downstairs and finish the day with a nice conversation with a glass on our hand. Thank you very much. Yeah, you're welcome. Just... Forum.